How to visit the center of the earth. Hello lovely YouTube family, welcome back to Weekly Tins. In today's video we're going to talk about how to visit the center of the earth. Before we start, I would want you to hit that red subscribe button so you never miss out on any of our videos. Traveling to Earth's center is probably a theme in science fiction. Some subterranean fictions involve traveling to Earth's center and finding either a hollow earth or Earth's molten core. Planetary scientist David J. Stevenson suggested sending a probe to the core as a thought experiment. Humans have drilled over 12 kilometers, 7.67 miles in the Sakhalin 1. In terms of depth below the surface, the Koala Super Deep Boreholes SG3 retains the world record at 12,262 meters in 1989 and still is the deepest artificial point on Earth. Hollow Earth. The idea of a so-called hollow Earth, once a popular in fantasy adventure literature, is that the planet Earth has a hollow interior and an inner surface habitable by human beings. Although the science community has made clear that this is a pseudoscience, the idea nevertheless is a less popular feature of many fantasy and science fiction stories, and of course, some conspiracy theories. In science fiction, the most famous example of subterranean fiction is Jules Verne's 1864 science fiction novel Journey to the Center of the Earth, which has been adapted many times as a feature film and for television. The novel is not an example of hollow Earth, as his characters actually descend only 87 miles beneath the surface, where they find an underground sea occupying a cavern roughly the size of Europe. The 2003 film The Core, loosely based on the novel Core, tells the stories of a team that has to drill the center of the Earth and detonate a series of nuclear explosions in order to restart the rotations of the Earth core. The drilling equipment, dubbed by Virgil, includes a powerful snake-like laser drill, a small nuclear reactor for power, a shell of unobtainium, a fictional material, to protect against intense heat and pressure and generate energy to drive the engine, a powerful X-ray camera for viewing outside, and a system of impellers for movement and control. The only part of the Earth that turns out to be hollow is a gigantic geode. And soon after the drill moves through it, the hole is created, fills with magma. Steps. The reality of exploring under Earth's surface isn't so simple, says Damon Teagle, professor of geochemistry at the National Oceanography Center, University of Southampton. Teagle has worked on 8 drilling projects worldwide, all of which extended just miles into the Earth's uppermost layer, the crust. Those holes might sound deep, but they're nowhere near getting to the Earth's center. Some 3,951 on average miles below the surface. How it's done in just 4 steps. Step 1. Pick a favorable region. The Earth's crust varies greatly in thickness. On land, it can extend nearly 40 miles. The deepest hole ever drilled into the crust stretches less than 7 miles. On the seafloor, however, the crust is far thinner, at just 4 miles. So if you want to improve your chance of reaching this mantle, starting your hole at the sea gives you a head start. The ideal drilling region is free from anomalies such as fractured seafloor, volcanoes, and seamounts, underwater mountains. Drilling regions are usually limited by crust temperature and water depth. The types of drills Teagle uses can't operate in water deeper than 2 3/4 miles or at drill temperature greater than 575 degrees Fahrenheit, which means steering clear of deep ocean or hot mid-ocean ridges. Step 2. Pick a good drill site. After a potential region is located, Teagle's team looks for the best drilling site using multi-channel seismometers, which help determine the structure of the crust, mantle, and the boundary between them. Seismic waves travel through Earth's layers at different rates, depending on their density and composition, and these characteristics differ greatly from one layer to another. Step 3. Drill baby drill. Now for the hard part. Drilling from the platform of a massive ship, which bobs up and down with the ocean's waves, requires GPS to keep the drill on track. The crust's rocky layers are incredibly hard, so the 12-inch diameter rotary cone drills advance only about 3 feet each day and must be replaced every 60 hours. Some of the drill bits are hollow in order to cut cylinders of rock for sampling, while others simply grind. Drilling can take 1 to 2 years, although Teagle calls the time frame optimistic. Step 4. Take samples. Once Teagle team reaches the mantle, a feat that hasn't been attempted in half a century, they'll start measuring the hull every which way they can in order to better understand Earth's geological, geophysical, and geochemical history. Just a few potential experiments include sending down seismic receivers while firing off shots in the surrounding water to more accurately measure to the layer's composition, sampling fluids to look for signs of microbial life, and measuring fluid pressures to see how the crust and mantle move relative to each other. Most would-be amateur crust drillers can't join an expedition like Teagle's, but if you're a teacher or graduate student, you might be in luck. The Integrated Ocean Drilling Program sends science teachers from kindergartens to college level on drilling expeditions, and the Consortium for Ocean Leadership offers training program for grad students to learn the trade. This brings us to the end of our video. I hope you enjoyed it. Hey, like if you did, and don't forget to subscribe to our channel so you never miss any of our videos in the future. Also watch the next 2 videos that are on your screen because I'm sure you'll love them. With that, I'll see you in the next video.